Okay, welcome back. This is part 2 of section 1.3, and we're still working on trig functions. So we are still in section 1.3. This time we're going to look at an equation of terminal side of an angle theta, but we're going to have some restriction on the value of x. So we'll say an equation of the terminal side of an angle theta and standard position is given with restrictions on x. So let's say here I have my angle theta, but I was told that x value has to be equal or greater than 0. So first I'm going to get theta to be here. Here is where x is greater than or equal to 0. That's the positive direction. So here is theta. But here in the fourth quadrant, I still can get a theta with x that's positive. I'm going to look at it this way. Let's say we have another theta here. This angle is still have x value to be greater than or equal to 0. So it's either in quadrant 1 or quadrant 4. Or we can say theta, in another case, has an x value that is less than or equal to 0. So I'm looking at this side of the x-axis. So I can have an angle here, theta, with the x that's negative, less than or equal to 0, or it could be here as well. This is another theta with a value of x that's less than or equal to 0. So it could be in quadrant 2 or quadrant 3. Let's look at an example where it says find the 6 trig functions of angle theta. But we're going to have a restriction on the value of x. So I was given that 2x plus y equals 0, and I've been told that x has to be greater than or equal to 0. I need to solve this to find the x and y value. But I've been told that x should be greater than or equal to 0. So simpler, or the simplest number to pick here for x is to have x equals 1. That's a number that's greater than 0, so it satisfies the restriction that I have here. So I'm going to plug in a 1 for the value of x to find y. And I'm going to solve for y. So that's 2 plus y equals to 0. I'm going to move the 2, subtract 2 from both sides. So y equals negative 2. So here I can say my point is 1. There's a value of x that I picked. And I found the y is negative 2. And you can pick any value for x that's as long as it's greater than 0. But we choose to pick 1 because it's easier. And now I have we said x is 1, y is negative 2. So here is my triangle, right triangle. Here is, here is theta. So as you see, I have a theta, an angle with x is greater than 0, but y is in the negative direction. This is 1 and this is 2. But I still need to find the hypotenuse. I'll apply r squared equals x squared plus y squared, Pythagorean theorem. R squared, I know x is 1 squared plus y is negative 2 squared, and that will give me r squared equals 1 plus 4 r squared equals 5. Take square root for both sides. R equals negative 5. Remember, R should always be positive. So we cannot have a negative value for R. Now I have x, y, and I have R. I can find the 6 trig functions. I'm going to start with sine theta. That is negative 2 over root 5. And then I have a radical in the denominator, so I will multiply by root 5, both the top and the bottom, and I'll get, this is root 5, and I'll get negative 2 root 5 divided by 5. Then you have cosine theta, and that is 1 over root 5. Again, multiply by root 5, top and bottom, and that will be root 5 over 5. So, okay, next we have tangent theta, and that will be negative 2 over the 1, which it is negative 2. Cosecant theta is simply the reciprocal of the sine function. So it is negative root 5 over 2. And secant theta is the reciprocal for the cosine. So that's root 5 over 1, which is the same as root 5. And cotangent theta is the reciprocal for the tangent. So it will be negative 1/2. Okay, next we are looking at, so we are still in section 1.3. We're going to look at an example to evaluate trig functions of quadrantal angles. And here you can open up your book to page 24, and there is a table here that is giving you the 6 trig functions for these special angles: 0 degree, 90 degree, 180, 270, and 360 degrees. And we are going to use the formation from this table to help us evaluating the trig functions. So number 1, we're going to look at cosine 90 degrees plus 3 sine 270. Again, that's on page 24. So if you're going to look at the table, you're going to see that cosine 90 degree is 0 and sine 270 is negative 1. So I'm going to plug in these values here. Set cosine 90 is 0 plus 3 times the negative 1 that I got from the table, and that will give me negative 3. Number 2, sine squared of 180 plus cosine squared of 180 degrees. Again, we're going to look at the table, and I see that sine of 180 is 0 and cosine 180 is negative 1. So I have 0 squared plus negative 1 squared, and that is 0 plus 1, and that's equal to 1. And last one, number 3, 3 secant 180 degrees minus 5 tangent 360 degrees. Then we're going to look at the table. We see that 180 secant is negative 1. So I have 3 times negative 1 minus 5, and tangent 360 is 0. I know that from the table. So that's negative 3 minus the 0, and that's equal to negative 3. Okay, that's it for section 1.3, and I'll see you later.